You can access these things again and again, and because I will definitely provide whatever that we have learned today uh, as a PDF file. I will send this, after saving it, and then you can access through multiple channels, because there are so many helps that is available these days. So it's nothing that I am doing something that is unique. So there are several ways to get those information, but still, attending a session like this will give you some exposure to those things, where to search, what to search, how to search. I mean, that may be, you will get used to, this programming language. So what I will suggest that you start doing with me. It's very simple. I mean, why? Because I guess my pace is slow as well. If you are not able to follow something, you please ask me to do it again or explain this again. Is that okay?
Is that okay, participants?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Good.
Yes.
So
Hello,
so
sir.
yeah, please
I
go
have
ahead.
one question, sir. I am facing a bit of network issues. If you can switch off your video, so
Definitely, I will do that. Definitely, I will do that, because I want to talk about mathematical model. I myself would not like to do the modeling part. So let me do that first.
Ajay
So
sir,
we
like any participant is like by mistake switched on their videos. Can you please tell them so that the network connectivity is proper?
Yes. So I will definitely ask, request participants to switch off their video, because that may be necessary for their budget for getting this uninterrupted lecture session. Mhm.
Thank you, sir.
So thank you very much, Devajit, for informing me, because I mean, it's not useful to disturb the bandwidth of network that we are having. Okay, so if you allow me, let us start again.
Yes,
No,
sir. Yes, sir. Please, sir. Please, sir.
okay, thank you. So can you see my screen?
Yes, sir. It's
So
visible, sir.
so we started with the printing simple hello, saying hello to all of you, and then we learned a few of the things from NumPy library, and we managed to see how to create a one-dimensional array, two-dimensional arrays filled with some values, arrays filled with zeros, arrays filled with ones, and then we found how to generate a sequence of number with some intervals. Sometimes within range we want to equidistant sequence we want to get. Then we also found useful function for reshaping one dimensional vector to two-dimensional shape, and then from two-dimensional to getting to one-dimensional again, with this arrival function and reshape function. These were the important two. Then we went with this random number, and uniform, from the uniform distribution we generated this random number, and how to do this with the other distribution, if time permits, we will see. Um, but there are formulas. If you know that's uniform, random numbers, from there you can transform to to the numbers or random numbers with originating from different distributions. But we will see that later. Then we started with thinking about how to access the elements of one-dimensional and two-dimensional arrays. And the unique thing that we saw here is that we can go backward as well as forward. This is what we have seen. And now let us go and learn this, you know, uh, the slicing thing in this, you know, array. And then we will move. So the slicing syntax is very similar to that you would have seen in your MATLAB. Very similar. And let me show you. We were having, you know, this D as a, you know, unidimensional array, and suppose we want to slice this D, and we want to say so slice the part of, say, from the third column to say uh, fifth column. So this is what we have given this information, that from this two represents the third index, column index, and 4 represents the fifth one. So let us see what is the result of this. So then you can see that it is giving you third and fourth. It has not given you fifth one. So can you see D where it was? Let me print first D. What was D? So can you see what is that we have printed? This is third one, and this is the fourth one. So if 2 to 4 if we are giving that, it is slicing here and slicing here. This is how this is working. Slice the for the one-dimensional, you know, array. So now suppose we want to extract an item and skip a specific number of following items. Then how to do that? So let us see. I want to this D. I want to start with the second column, and then I want to go up to, say, fourth column, and then I want to do it by skipping, you know, one column in one go. So that's why. What is that? I am getting this 3.33 is the first one it was, right? And after that it has skipped 6.66, and then it has given 10, right? And because I wanted it to go to up to this one only, because 5 is the, you know, here the range that we have given. So 1, 2, 3, 4, 5. So it cannot print this, and it cannot print this as well. So the slicing works in this way. You can think of skipping, you know, some of the values as well, but the pattern should be same. So this was another unique thing that I saw that was maybe that can help you. So what else? Now you can choose to not provide some of the details, but the columns here, columns here actually represent the same information. So if you will not provide, it will go and presume the default values there. So if suppose you are not providing first one, then it is going to say that it will take first as 0. And if you are not providing the second element here, then it will say whatever the last the last column index it is. It will assume that. And third, if you will not provide, then it will generate all. So this the unique the default value here will be 1. This is how you can see. Okay, now let us think about the same thing for the two-dimensional array. For example, let us first come up with one two-dimensional array again, and then so b, what happened? B equal to np dot random dot random, and then maybe saying 16. So this will be one dimensional, and if I'm saying random and 4 4, whether this is going to work or not, I have to see. Yeah, it works. So 4 cross 4, matrix that we have generated with this random numbers and that have stored in B. And now suppose I want to know, I know this slice it smaller matrix. Um, so suppose I want to get this sub matrix of this 0 to of 3 dimension, maybe say. So let me say I want to give this print of 0 to 2 and 0 to 2. So what is that it will print? Anyone? What it should print? The slicing, if you can see, the way we are doing here is this is the 0 index for the row, and this is the 2 index for the row, and here 0 index for the column and 2 index for the column. What do you think that it will print? It should print the sub matrix of value containing these three, and these three. That is what my guess is. Let us see. Oh, what is that? It is happening. Oh my God! No, it has taken only 2 columns. So why this is doing 2 columns? We have seen this here. If you can notice that what is that we have seen here? See, the 2 index was the initial index. This was the 2 index of array here, and that's why the third column it has taken in that. And this was the 4 that we supplied here, but it went up to the 4th column only, not the 5th column. So why is that? It actually what it does that for the last one it takes one less index, and for the initial one it is taking the same index that you are giving. So that is how it has happened here as well. So 0 is the initial one, so that's why this number appeared. But then this 2 is the dimension that is telling that it will be only having this 2 cross 2 submatrix, and not 3 cross 3 that I was thinking to get. For 3 cross 3, I will have to supply 3. What if I'm saying I want another submatrix rather than this? Although the same dimension, but this will start from 2 and this will start from 1, whether this is possible or not. So let us see. Oh my God, this is not possible. Why this is not possible? Now, this is saying that you have to, uh, you have to generate indexes in a proper manner. So why this is saying 1 is to 2 is has not worked? Because the dimensions are not matching. So maybe if I am saying, will this work? Uh, Again, this is not working because this is 2 is to 2. Okay, okay. Just a minute. 2 is to 4, and then 1 is to 3. Now it is giving. So now you can see what is the first element we are seeing. First element is having the index. Row is third row, so 1 2 3, and column is second. Why? Because this is what we have given, and the dimension of how many rows that we want is from third to third, 3 and 4. That is what we wanted. So and 1 2 3, this is what we wanted. So this submatrix that we have. So several times you need to partition your data matrix, and this will be helpful in slicing two-dimensional or say matrices. Okay.
Sir,
Yeah.
so for 2 is to 2, we will just take 2, and then because we are taking another 2 is to 2, I guess it's starting at 2, but it's not including 2. That's why I guess it is showing
Yeah.
that shape error.
Right, right. So it's so the first one that you are seeing here, it is the column index. It is telling you, and then it is the up to 4 it is going, and this is what it is saying. So row is going from from the third row to fourth row, and it is saying the column will move from second column to third column. This is what it is saying here when we gave this command. Is that okay?
Yes, sir.
Good. So now let us think about um, loop. Maybe let us see the loop first, and then we will go. So, for example, for loop is here, and the command here is very simple to follow. For I in and in, let me say B. Um, for the we were having one in D. So what unidimensional array for I in D, and now see the indent is going to work. You have not to give any braces or anything like that, and this is going to work. Simply, it is going to give you all the elements that you have in that array. Let us, if we want to do this, for the two-dimensional array, if you want to print the rows, there is a simply we can say for row in D, sorry B, and then again print row. Now, what is that you can expect that each of the rows will be printed, you know, in each of the iteration. That is what. So this is very simple way of writing a loop here. Hmm. You can think of printing, you know, every item in two-dimensional array as well, simply by one command. So maybe for I in, what you have to write here, that b dot flat. So colon and then print I. So each of the values in that b has been printed here, and you can see how it has printed it. It went in this fashion and then in this fashion. So it traveled, you know, first row and then next row and so on. So these maybe these are useful functions that you can think of. Now let us think about, you know, defining functions. Say, well, very simple function definition that you can think of. For that, you have to write here a command def. क्या हो गया? So def and then any function, maybe say function one, and then any argument, say x, and let us return. Oh, sorry. You have to put this colon here, and then let us return simply maybe something like twice of x. Now what? Now think about, you know, printing this function one by giving supplying something like 3. So it returned, you know, the value 6. So in this way, you can think of writing a small function as well. Now one more thing maybe. So for example, we were having this in B random matrix, and we wanted to suppose know which of these values are less than 0.5 maybe. For that, we can use, you know, a very simple operator. So this is Boolean operator that will give you. So this was B, and I want to, you know, print the value wherever the value is less than 0.5 or say 0.25. It should present, you know, true for that, you know, those indexes. Otherwise, it should give false. Let me see what it is giving you. So this is giving this false. First value is false. Second is true. then false, and so on. So this operator simply worked here on even two-dimensional array. You can do it on one-dimensional array as well. Now you want to collect those, suppose the values that were uh, that is less than 0.25. So for that you can write simply b, and inside this you can write b less than 0.25. Now this will simply give you all the values in b which is less than 0.25. So now you can see that every values in that random matrix as a list that you can see here, which is less than 0.25. So in this way you can extract some of the elements. If you want, say, something that is greater than 0.95, sometimes you need this. So just put this greater than 0.95 and then just say, oh my god, what happened? D type is float. So less than operator worked and this will not work. Why? Okay. Okay. Sorry. Why this has not worked? This worked actually. If you can see, what is that we got here? We got here, this empty array. That is what we got here. So this worked actually. Why? Because we already have, put in B only those elements of B which were, less than 0.25. So no element here in this B now is greater than 0.95. So definitely this this will give us, uh, empty array. Now B is empty array. You can see if you are going to say B, you will get empty array. That is what. Oh my God, no. B exactly is the same. Then why this not worked?
So there is no B value greater than 0.95, sir.
Okay. Thank you. So, I was really surprised. Why? I thought that maybe this B they are when I'm printing it is again going to overwrite on this B. This is not true. That so thank you very much. This is not true. B actually is the same. We have just printed the values that were less than 0.25. It is not going to overwrite on B. And this was giving us empty array because in the original B as well we were having no value greater than 0.95, and I was really surprised to see. I was not expecting that there will not be any value greater than 0.95. Thank you very much. So so we have seen this a little bit of manipulation here, and we have seen some shaping manipulation as well earlier. So we will not go into that, and then we will see how to join array. So there are two ways to join array. This is we call this horizontal stacking and vertical stacking, and that is what we will see. So let me see. Let me start with again defining this a equal to say np dot so that it will be visible to you, and that's why I'm doing and zeros. You know, say 3 cross 3, and then b equal to np dot once and 3 cross 3. And now I want to join this A and B into another matrix, vertically stacking. Now let us see what I mean by vertically stacking, and then so what I am going to write here, that my C matrix is equal to this np dot stack, but a stack is here. I need to define the vertical stack, stack, and I'll have to provide the arguments as these two matrices A and B. Sorry, B. And now I want to print this C. What is that we can expect? So vertically stacking, first one A is zeros matrix of 3 cross 3 dimension. B is the ones matrix of 3 cross 3 dimension, and I'm putting this in C, and this C matrix that we are seeing is the vertical stacking of A and B. So B is B and A are stacked vertically. This is what we can see. So first A appeared, and and in the vertically in the downside you are having this B. So this is one thing that we can see. Now let us see this the horizontal stacking. This is again D equal to say np dot for horizontal stacking, just this function as stack h stack now. And the same way we need to provide this two matrices. So dimensions should match if you want to do this stacking thing. That is we should be careful of.
Hello,
Yeah,
sir.
please. Yeah,
So
please.
the matrix, why everything has a point? I mean, 0 point, 1 point. I mean,
Oh,
you haven't
okay.
mentioned any of the float.
Because if you have if this is the type here is the floating type, and that's why this is 0 point here.
But sir, nothing has been mentioned. Like we have mentioned np dot zeros 3 comma 3, np dot 1. So nowhere a float is mentioned. So by
Right.
default, it is taking
By
float.
default, it is taking as a floating type.
Okay,
By
okay,
default,
okay.
it is taking as
Okay.
floating type.
Okay, sir.
This is so. This is the way that you can see the horizontal stacking here. There are two more functions in stacking, which is column stack and row stack, but this is more or more with one-dimensional stacking. So with H stack and V stack, I mean that is more general than column stack and row stack. So maybe I'll skip that. Yes, we can do splitting in this as well. But split function is also not so so good. I mean, for example, if I want to do this say vertical split of this C. So let me say again, I want to reconstruct my A and B. Now I am putting this A and B small. This equal to I'm saying np dot h split. Sorry, V split, and I want to split this one. that's capital C, and in two parts. So A will contain the first part of vertical split, and that is the zeros that I am expecting, and B will contain the ones, that is what I am expecting. Let me print A equal to A, B equal to B. So the same way that it worked, and it has split this matrix into two parts. But I mean, height of the array is divided by two. That is what I can see, but I have not seen this very useful function, and there are so limitations as well. So splitting, I have found that it is not a very good thing to do. Maybe we can use slicing, that gives more flexibility. Okay. Now we can think of copying as well. So we the same way that in any other programming language we see that there you can declare another variable to be copy of first variable. But the copying is just putting another name. It's just, for example, you may be called differently in different um, gatherings, or say your friends would be calling you differently. So there's the same way. So if there is any change there in one of the variable, that will be reflected in other as well, if you will call by that name. So this is just name that you are getting. So if you have to exactly copying, and you have to make another copy of that, then you will have to assign it. That is how you can do. Okay. So for that, there is a function for copying as well. So for example, here, if you can see, let me show this. So a small a that you are seeing here, and now I'm saying, rather than b that you have seen here, I am saying b equal to a. Okay, and then I'm saying my a um, A 0 0 0 equal to 1, or say 2. Okay, and then I'm saying print and I'm lazy. Print both of these things. So what do you expect? What is that will happen? Whether there will be difference in A and B? Anyone?
Yes, sir. There will be a difference.
So let us see. No difference. And that is the problem. The problem here is that the A was a matrix, and we named it with another name when we assigned B equal to A. just this much. So that's wherever this was created in memory, right? The same is being addressed by A as well as B now. So both of the, if you are calling A or B, you are calling the same location, and you changed it, and then you call it, so it is calling the changed value here. So that's why it is the same thing that has appeared. Now we want not to do this, so then what we will do? So for that, there is a function here, and that is what we will use. Rather than saying b equal to a, we will say b dot copy, and sorry, a dot copy. This is what we will say. And now I am changing this to say a00 equal to 3, and then I am reprinting. Now you can see now it is different. So a is the value here gets changed, but b was having the same value that before change that we copied in b, or give reference to. Or is that okay? So
Yes, sir.
so this was important, because this may be confusing. No, that you are changing and still change is not getting reflected, or you are expecting that both of the things are different because you are changing only one thing. Actually, this is giving reference to the same array location. Okay. Now,
Sir,
yeah, please.
sir, in the previous case, when you have assigned b equals to a, and after that you
Right.
printed b, so it is assigning the value of b as it was of a. But in the next case, when you mentioned a dot copy, so it is assigning the value of b, which was the previous case the value of b. So why
Right.
not in this case? It is like when we mention the code copy, does it goes to previous case, or doesn't it cover
No.
this
So
single case?
here, thank you. Thanks for asking this question, because this needs clarification. Yeah. So here, a was an array. So there was a location which it was referencing to. When we said b equal to a here, the same this b variable is referencing to the same location. But when we are saying b equal to a dot copy, it is creating another array also, and at another location now this is going to store. Not, it is not going to reference to same location that a is referencing. Okay, so this is the difference that we are having in both of these approach, because this function will create another array, right, and then we will copy the values of a into that location,
So
right.
is it
So this
because
was,
we are making a copy of a of the previous case and then we are changing a, right?
so this, yeah, so here it is by, assigning by reference thing, and here it is by value. This is the copying by value, copying by reference. So this is what the difference here it is. Can you were able to understand this? So I'm saying that a was referring to a location where this was stored. This array was stored, so it was calling to this reference, this location. Now when we said here b equal to a, b is also going to refer to the same location. Okay, so this is assignment by reference. Okay, so b is also calling to the same location, and that's why even when we changed here the value here in this location, first one, in both of the B and A, I mean, because they are referencing to the same location, the change will get reflected. Is that okay? But when we are saying B equal to A dot copy, both of the arrays A and B are at different location now, because this is a new location at which B is being created. Is that okay? Just the values are same here till this line, and then we changed in the A, not in B, and that's why you can see that in the A there is a change, but in B there is no change. So this is by value that we are changing, creating new array. Is that okay?
Yes, sir. Understood.
Great. Thank you. Now, very important thing and very unique thing maybe that you can see NumPy gives you is this is known as broadcasting. So you can do several times. We have to create do this element wise operation in matrices, and sometimes with some vector we want to do it element wise in the columns or in the rows, and that flexibility does broadcasting gives you. And let us see this. This is very interesting uh, application. Okay, uh, let me begin this broadcasting. So sorry, I am having this A and B here. Let me create one more. C equal to 1, 2, 3, 4, 5, 4, 5, 6. C equal to np dot array 4, 5, 6. Now what I want here that now see A is a 3 cross 3 matrix. Uh, C is a list of 3 elements. So maybe this is a vector, and I want to broadcast this C over A, and that simply I can do in this by just calling A plus B. Now what is that we are expecting here, that 4, 5, 6 should be added to each row element wise of A. So now you can see that this 3 has been added, 3 plus 4, 0 is 5, this 0 is 6, and then this 4, 5, 6, 4, 5, 6 added. So this is the way that you can do this element wise addition here. So this is known as broadcasting. Now there is a rule. Not every everything we can do here. For example, we could have done this as well. So for example, let us say C equal to only say 7, and then I'm saying A plus C, and this will what it is going to do is that it will add 7 to each of the element of A. So this is unique to Python that I have seen, that this is simply overloaded operator in such a fashion that it can work still with um, even if dimensions are not matching, still we can do something. But not every way we can do. I mean, there should be there is a rule of doing this. What is the rule? So wherever you don't have dimension match, For example, here A and C dimension is not matching. A is 3 cross 3, C is 3 cross, sorry, 1 cross 3. Um, so basically 3 actually, yeah. So what it will do that it will say 3 cross 1, and then it will simply do, you know, broadcasting. So maybe we need more explanation about that. So broadcasting has some rule, and the first rule is that the length of each dimension must be equal, or one of them must be equal to 1. This is the first thing. Either both of the dimensions will match, or one of the dimension in one of the um, mm, vector should be equal to 1. If neither of these condition is met, then you get an exception, and that maybe you will not able to do this broadcasting. So there are two rules of broadcasting. First, you must add 1 to each missing dimension, and after that, if the compatibility satisfies, then you can apply broadcasting and move to second rule. The second rule is, I mean, how to extend the size of the smallest array so that it is the size of the biggest array, so that element-wise function or operator is applicable. So second rule assumes that the missing element are filled with replicas of the values continued in extended size, and that is what you can see that here. What it does that C was 456, and the replica of 456 was created 3 times to add into this A, and that is element wise, and that is what it has done. Here the one of the dimension was matching, so compatibility was there. So this broadcasting is unique, but still I will say that I mean, rarely people use these things. Why? Because people are not accustomed to, you know, broadcasting. But this was a unique thing in Python. That's why I gave you this flavor of this. Now let us do one more thing, and then we will go to Pandas. And this is about, you know, saving your data. So suppose I'm having this where it is somewhere it was, yeah, B, capital B is there. I want to save this matrix. So this data, maybe I'm saying that I want to save, and then I will write this np.save, and then I will name that, you know, that data file. Let me say bmat. I'm putting this name, and I will just give you know, this what is that I'm going to save there. So this will get saved in the you know, in the parent directory, in the directory where your program is there, and with this name bmat.npy. This is how it will get saved once you will execute it. And then suppose you want to reload it again. So let us name this as b1mat. This I'm going to reload. I'm saying np.load, simply load, and then I will say my the 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 matrix that I want to reload is the named is bmat dot npy, and now I want to see whatever we have loaded is the same thing that b was or not. So I printed bmat. So now you can see that where was b, capital B, capital B, np.1 c 33. So the same B was saved here in B1 mat, and B1 mat we got this array here. So in this way we can save data in binary files basically and then reading that the same file. Okay, now we can read files from tabular data. So for example, text file or CSV file as well. And let us do that as well. I'm getting some voices. Okay. Am I still there? I don't know. Are you able to hear me? Okay.
Yes, sir.
Okay, thank you.
Yes, sir.
Thank you. So we will see how to deal with the CSV data and others as well. For that, there is a command that is gen from text or gen from. That is what we have seen. Gen from text, yeah, and that generates or that reads data, and whatever the delimiter form that you are having. For that, I need to put that in somewhere. Let me see. We will do it in Pandas rather than doing with this here. So maybe let us skip for a while, because for that I need to go to some location and then create this. So let us go into and yeah, this pandas. This is another very important library. We have seen this NumPy. Pandas are very important library which helps you in manipulation of data. And two data structures that are important here are series and data frames. So we may have enough time to go through this series and pandas data frame. What I will say that pandas a little bit difficult to master. I mean, why? Because there may be, something that all the packages you may not get, in one of the version, and you can struggle a bit. But if it works wonderfully well. So for that, again, you have to use this import this package pandas as PD maybe, and then let's start with first structure, that is series, and let us say create one series s equal to PD dot series. You will see definitely that what is sorry. Now you have to be very careful that S is capital here, PD dot series, and I'm providing a list to this, and see what is the difference between what we were doing with array and what we are getting here. Is suppose I'm putting say 3 7 sorry 7 4 3 7 4, maybe 6, maybe 1. Now, now let us print this. What is that we are getting? There is a difference between what we were doing with, NumPy and what is that we will be getting as PD. Now you can see that you are getting this, location as well, that, and the first index you are having this 3, and the second index you are having, and this is how it will look like, in if you are giving one, Now you can change the index as well. Now, if for example, rather than saying this, I wanted to say that index are not 0 1 2 3 4. Index was something else. So this was, my series, and then I provided another information about index equal to, say, A, B, C, D, and now I'm printing S. So now we are having this, index as A, B, C, D, and the values for that A, B, C, D, yeah, corresponding values are 3 7 4 6 1. So now you can access only values by calling s dot values, and only index by s dot index. So if you will call s dot values here, you will get the values, and if you will call s dot index, you will get, so s dot index, you will get the indices. Now you can think of, specifying the key to get any value. So for example, if we want corresponding to C, what is the value? So I will put this, and I will say, C, can you give me the value corresponding to C index? And it will give me the value 4. I can give the same way in what is at the third index, and and this will be again, this will again give you the value. So both of the way we can access this, that is what I wanted to tell you. We can change the value as well. The same way we can access the way that we have printed. Now we can also do this, both of the things in a way. I mean, using NumPy's arrays in creating pandas, or say a series. Okay, so just you have to, rather than the way we have provided here, this series, we can provide that array here simply and nothing else. So that is not going to change too much. Right. Now, suppose we want to do some filtering here with this, S that we are having this series, and we want to know what are the values that are greater than 6, say. So we can do this simply same way as greater than 6, and then done. Now let us see what are the values that are greater than 6. So only one value that is greater than 6, and that is with at the index B. This is how we can do. So filtering thing you can do easily. The mathematical functions as well we can do. Simply suppose each of the value I want to divide by 2 or multiply by 3, you can do that. So I'm saying let us simply do this S multiplied by 4. What is that we are getting? So each of the values has been multiplied by 4. So you can divide as well. You can take log of this simply. Okay. So there are lots of things that we can do. We can give same index as well. I mean to 2 values. So it's and the values can also be repeated. And there is this. You don't need to give everything. For example, let me show this. So rather than this, I'm saying now my S is this is 4, this is also 4, and now this is A, this is A. Let us do this, and then so repeating even in indices, even in values is not going to be a problem for us. But if suppose we want unique values, then how to do that? We can get this function is unique, that is there. Just saying unique will give you all the unique values here in this S series. Now you can think of value count as well. So how that may be a useful thing. So let us say S dot value count. This function is like this: value underscore counts. So this will count how give you the whole histogram of this. So how many times 4 was there? So 3 times. 6 was there 1 times and 3 was there 1 times. This is what that we got. So in this way you can generate um, all the things that you can see in the series. Another interesting feature of Python is that this not a number thing. Generally, this is a very problematic thing in any data file. This not a number, and this needs to be managed. But here you can give not a number value N A capital N in your series as well. So it is defined under um, NaN is defined under this numpy. So for example, I can think of putting my series S, yeah, and I want to define this value is not a number, so I will say np dot NaN, and that's it. So and then if I'm having this S, C, you can say corresponding to C, the value is NaN. So now there is two functions that may be important here. That how to say that whether this is null or this is not null. So null here also count this NaN as well. So if say I'm saying if what is null here, so S dot is null. This is a function. So wherever null is there, also not a number is there, I mean it will give you true. Otherwise, it will give you false. This is what you can expect with this. So in this way, yeah, here you can see. In this way, you can you can identify your missing numbers or not a number values in your data easily. You can collect all those where true it is. I mean by saying let us say S1 equal to S and then S dot not null. Now what you are expecting, what you will get here in S1? What are the values that you will get here in S1? Anyone? So only data corresponding to C should not be there, otherwise everything should be there. So this is how we can see that we can collect all those information where the value is there and not a missing number. So this may be helpful. Okay. Now you can see this series as a dictionary, and you can start generating a dictionary, but we have to be mindful here that the primary key should be unique in that case. Okay, if you are creating a dictionary. So Let us do this, and then we can do some of the operations on dictionary as well, or maybe series as well. Let us say starting this, first we will create a dictionary. This is the usual Python data type that you will be having, saying maybe I'm putting this dictionary as dict1 dictionary equal to, let me create this. So this is a dictionary. This is how dictionary is created. So I'm saying maybe R, and corresponding to R there is a value, say 45. Maybe then we are having, say, W, and corresponding to W there is, say, value, say 92, and then maybe there is another, say, K, and corresponding to K there is value, say 56. So suppose this is one of the dictionary, and I want to create a series, a Panda series with this dictionary. So I can create that as well. I'm saying s2 equal to, or pd dot series, and then I will provide this dict1. So simply I can create or initialize my series with a dictionary, and then I can print that. Let me print s2. So here we can see that my dictionary is now as a series we are having here, and we can think of creating another dictionary and adding this dictionary as well. Let us see. So I'm putting dictionary 2. Now I am changing something here. This is 5. This is 9. And rather than K, there is a D. And this is 6. Now this is another dictionary that I am having, and I'm interested in joining these two dictionary, or say adding these two dictionary. So I will say s1 plus s2, and let us see. No, sorry. Let me do this first. Control P. This is s1. D2. Yeah. So s1 plus s2, and these two dictionary will get joined here. Why it is giving D not a number? R is 50. Okay, why this is happening? Because corresponding to D, you were not having here, any element, and this is, corresponding to D, it will add 6 with not a number, and that's why not a number is there. Corresponding to K, you are not having any number in in S1. So again, not a number. But corresponding to R, here is 5 and this is 45. Both of them has been added to 50. Corresponding to W, this is 92 plus 9, and this is Y, this is 101. So in this way, the series can be added. These two series can be added, in which each of the indices element wise it has been added, and if there is a missing number, now you are getting that getting corrupted in resultant as well. So this was about series, and then let us get this games of data frame as well. And so most common way is to pass a dictionary to create a data frame, and the same way you're just saying f1 equal to this frame pd dot data frame and then I'm passing this, right? S1 plus S2 maybe. Can I pass? And then I'm saying, publish my F1. So here now you are getting this, this as your data frame, but we haven't named this variables here, but you can see the structure now corresponding to D. This is name, and this is a nice structure. Now you can name this these variables as well. Let us put that in a way. Let me say data 1. First, I'm creating a dictionary, and then I will go and create a frame, and then I will print again. So you can see that how you can generate color. Maybe I will put color as this one. Okay, and then maybe another field is object, and maybe for object I will put okay, and then let me say price, and for price I'm putting something like so this is maybe one of the dictionary that I created, and now I will create f2 equal to pd dot data frame pd dot data frame, and I will pass this data one, and then I want to see what my f2 is telling me. And now you can see that the names of these variables are there. This color, object, price, and this is the index that you can see 0, 1, 2, 3, 4, and corresponding values that you can see. The very nice way you can you can come up with your representing your data using this data frame. You can see the difference what it is creating. Now dictionary is very well represented here. You can do lots of things with this data frame. you can put this index here as well if you want, as in in other ways. Okay. Now, if suppose you want to select some of the elements, and suppose you want to know what are the columns of this F2 that you are seeing. I mean, you want to know the variables that. So for that, you just have to type, that you have created this data frame. Just you have to type f2.columns, and it will give you what are the what are the variables that you are having, and then if you want values, what the values that you are having, so you can just create f2.values, and then you will get all those values that as an array. So you can retrieve whatever that you want to know. You can just get one of the variable as well. For example, if say I'm saying I am interested in f2.price, so I will say f2.price, and that's it. And I will able to retrieve f2.price. So index here is starting with 0, 1, 2, 3, 4. Corresponding price is there. So in this way we can do we can extract information from data frame very easily. At any location also we can get, and we can do this. We can assign as well. So maybe let us think about assigning. Yeah, any question till now?
No, sir. Understood.
Okay. Okay. So suppose.
No, sir.
Okay. Okay. So suppose we want to add one more variable to it. This same data frame that we were having. So so let us do that. What we are going to do is I want to update or first create a new column in this F2. So the idea here is that I will say F2, and then in this I will say this. We can put this some name here. The variable name may be say quantity, QTY say. And what is the quantity? What is the quantity that we are going to put? So suppose we are saying the quantity is this one. Say 2, 7, 4, 5, and say 0. So now if I'm going to say my F2, show me what is my F2, then we will see that there is another variable that has been added here. So the lots of flexibility you can see with this data frame. You can update as well, and you can think of whether something is there or not. Okay, So for example, in object, you want to see that CC is there or not. Okay. CC is there or not. So for that, let us say f2 dot is in. This is the function that you can use, and no. So I was thinking about the object CC is there or not. Uh, how to check is in CC, whether this will give me f2 dot is in CC. This will give me error. Why? Only list-like or dictionary-like objects are allowed to be passed in data frame. And that is what I was expecting. And if I am saying that this is what I was expecting, if this is what I am asking, then okay, yeah. Now I was not asking this. I was asking let me see. I'm not sure what I want to show you is going to happen or not. Whether this will work. Okay, yeah, this worked. Okay. So in object, I was thinking that whether CC is there or not. Let me see whether AA is there or not. So I gave this f2 dot object, and then I am searching whether AA is there or not. So yes, there are three elements in an object with AA. Let us see whether this was true. Yeah, this one, this 2 and 3. So that means is in will give you about the membership, whether a value is present in particular field or not. You can check row wise as well as column wise. This is how you can do. Now, if you want to delete a variable, how will you do that? So for example, we created this quantity variable and we want to delete this. So for that, there is one command to write this DL and then write this the name of this data frame, and then whatever variable that you wanted to delete. Say for example, quantity I wanted to delete. So that's just QTY, and then I'm saying what is now my F2, and you can see that that variable has been deleted. Okay, so in this way, you can also think about filtering this database. For example, if suppose I want something less than equal to 4 price, maybe, yeah, or here. So then what I will do that I will say F2 and then I will say F2 dot price, and this should be less than equal to 4. Let see whether this is working or not. This worked. So it is going to give you, this, uh, the values of, or say, or the rows for which price was, less than equal to 4. So I have overshoot, I guess. Sorry, somehow I forgot, this, that time that I have used more than what I was intended to. So, what is that I need to do now is first to stop this presentation, and then will would like to say you that this is a very, very easy data structure to follow, and this gives you very much flexibility in doing all the operations that you see in your Excel that you can do here as well. So I'm stopping here, Professor Ajay.
Yes, sir.
So I guess I have consumed my whatever time that you have allotted to me.
Yes, sir. I would like to thank you for accepting my invitation and to give such a wonderful talk. Sir has taught about NumPy, Pandas, and I think the participants got a lot from sir. If you have any question, I'm saying to participants that if you have any question, you please ask. Kareem and Sarthak, yeah, you may ask questions.
Sir, while we were looking in NumPy exercise, so there was that you made us that there was a matrix, and we can this is f2 dot price is less than equals 4. So in the same way, in the NumPy matrix, we can do that. We can look for an element which is greater than 0.2 or less than 0.8. So is there a possibility that both the values can be checked, like if the value is greater than 0.2 and less than 0.8?
Yes, yes. For that we need to put this operator, and operator there. That we have to do, or nested way we can do filtering. Yes, we can do. I was not having time to do that. That's why I stopped there. But in nested way that we can do this filtering. Otherwise, we will put the operator there.
Achha, thank you, sir.
Any other question? So, sir, I would like to thank you once again. And we will be meeting again if I will do some other FDP. Thank you once again, sir.
It's an honor. Thank you very much for inviting me. I really liked interacting with you all, and I like teaching this is a fascinating programming language of Python as well. Thank you very much.